This is SLI, number 4 odd answers. So we just need to match those. So let's see, problem number 1 looks like this. So let's go ahead and solve it. So I had 5 on both sides. Those cancel. 6y is greater than or equal to 12. Divide each side by 6. So the inequality stays the same way because I'm dividing by a positive number. So we need to look for where we have a solid dot at a 2 going to the right. And that looks like answer C. Number 3, again, we're solving it. 4x plus 3 is less than or equal to 11. Subtract 3. Those cancel, so negative 4x is less than or equal to 8. Divide each side by a negative 4. Remember, the sign flips over because I divided by that negative. So sign goes opposite. So I get negative 2. So I get negative 2, solid dot going this way, which appears to be letter B. Number 5, we have 4t plus 11 is greater than or equal to 7. So let's subtract 11 from both sides. Those cancel. 4t is greater than or equal to, oh, is that going to be negative 4? Divide each side by positive 4. We do not flip the signs because this was not negative when we divided it. So I get negative 1. And then we want to graph the solution. So 0, I get negative 1. I got a solid dot and want values bigger, so it's going to shade that way. Number 7, I have 5 is less than negative 2t minus 3. We'll add 3 to both sides. So those cancel, so I get 8 is less than negative 2t. At this point, you might want to flip the whole thing over. Now, this sign didn't flip over because I did multiply or divide it. I just changed the sides of everything. Divide each side by a negative 2. This is going to flip over because this was negative, and that's going to give me a negative 4, and we just want to graph it. So I get 0 here, negative 4 here. I have an open dot going less than, looking like that. Number 9, 2 plus p over 2 is greater than or equal to 7. So a couple things we could do to this. We could multiply everything by 2 first, and that would clear our denominator. We could have subtracted 2 first and then multiplied by 2. It's your choice which way you want to do it, but either way is going to get you the correct answer. Subtract 4 from both sides, so I get p is greater than or equal to 10, and we still want to graph it. So if I had 0 down here, I got 10 over here. I have a solid dot here, shading this way. Number 11, we want to solve these and put them in interval notation. All right, so if I go ahead and subtract 5k from both sides, oh, note this, those both cancel out, so I get negative 7 is greater than 8. This is a false statement. Okay, that's not a true statement at all, so there is no real solution. Sometimes they might say empty set. It's your choice how you want to say it. Number 13, 7 plus 9y is less than 19 minus 3y. So let's see, maybe add 3y to both sides. And we can combine these two. I'll subtract 7 as well. So those cancel and those cancel. That gives me 12y over here is less than 12. Divide each side by 12. So y is less than 1. So we want values that are negative to up to 1. So remember, we're left to right. So negative infinity to 1, soft bracket because we don't have an equal sign. 15, I have 4k minus 6 is less than 3k plus k minus 1. Well, let's combine those like terms first. And notice I subtract 4k from both sides, so our variables go away. Is negative 6 less than negative 1? That is true. So this means we want an interval notation, so I can plug anywhere from negative infinity to positive infinity in. That means all answers work. And then number 17. 9p plus 2 is less than or equal to 3 times 3p minus 5. Let's distribute the 9 over this. So I get 18 is less than or equal to 9p minus 15. If I subtract 9p from both sides, those cancel, so I get 18 is less than or equal to negative 15. That's false. So we could put just empty set. Sometimes they put it in brackets like this. So it's kind of how there's not a real solution to this. And that's all we have.